In this video, we will find the electric field from the concentric charge shells that have same magnitude of charge density as it is shown in the figure. Don't focus too much on the result shown in the table below, but focus on the approach to solve the problem and have the understanding on how the graph should look like without doing too much mathematics. Let us begin. We will assume that you know electric field of a charged spherical shell. In case you do not, please watch the detailed video that is intended to also provide a qualitative understanding. The video will pop up at the end of this video or refer to the link in the description. Let us proceed. There are three charged shells that we need to consider. When we consider them individually, you know the solution as it was shown in the previous slide. Since the charge density is same, the charges in each of the shell is this, sigma times area of the sphere. For negative charge shell, the charge is obviously negative. The electric field for each of the shell based on the previous slide is this. Now we need to bring them together. The beautiful thing is, their electric field from each shell can be simply added, vectorially of course. Since they are brought together with same common center, the vector addition of the electric field is very simple. We just have to take care at each of the boundary as the electric field is discontinuous at each of the boundary. But the physics is done. We just have to do the math now. Let us do in the next slide. In this interesting slide, we will justify the graph without the math. We just need to know how the electric field behaves for one charge shell. At the same time, we will also calculate the exact electric field in each of the boundary areas. Let's start from the innermost charge shell. Here, the electric field is 0, as it is inside all the three charged shells. Now let's go to the next boundary, which is between the inner two shells as shown in the red shade. There will be no electric field contribution from the outer two shells. The inner shell has positive charge, which will go as 1 over r square for r greater than a but less than b. Hope you have understood so far. Now let's check the space between outer two shell as shown in the green shade. In this space, the contribution of electric field will come from some of the charges from the inner two shell, which is overall negative. So while the electric field goes over 1 over r square, it goes from more negative to less negative. Lastly, let's check the space beyond r greater than c. The contribution of the electric field will come from some of the charges from all the three shells, which is positive. The electric field goes over 1 over r square as shown. One last thing. At r equals to a, b, and c, which is the boundary, the electric field is discontinuous, which is perfectly fine. Hope you have understood. And now look at the last summary slide. Do check for other videos mentioned in the description or that appear in the last screen. Bye bye.